All right, folks, I'm ready to get started. Welcome, everybody. Welcome to the beginning of the fourth week together. The last week before the first exam, so things are about to get, relatively serious. It is the first exam. It is not the defining component of your grade, but it is one of the defining components of your grade. Your grade is determined by how you do on the exams. Everything else just kind of supports that. But if you're not doing well on the exams, you're basically not demonstrating that you're learning anything in the class, which is ultimately the point of the class. So please do your best to do well on the exams. But if you falter on an exam, it's not the end of the world. There's other opportunities, whatever. That's not something to sort of depend on, but it's also a means of sort of kind of quelling like maybe big fears that you may or may not harbor about a forthcoming exam. Just don't freak out about an exam ever prior to it. Just do your best in preparation for it. Spend your time wisely leading up to it. Make sure you're doing everything you can to do your best on an exam, and then whatever happens, and then you just kind of adjust your approach accordingly based on your performance. So the first exam is sort of like a litmus test, a test to see how you're doing, how your approach is working, whether or not it is or not, et cetera, et cetera. So just don't let the anxiety of exams ever get to you, because then that does stop you from being able to just be focused and just saying, okay, I'm gonna just every day do whatever I need to do to prepare for the exam or prepare for my other classes, or make sure that I juggle my time in a way that will allow me to be as effective as possible during those times that I need to be. Ideally, you have been, as I've been suggesting from the first day, learning the stuff as we've moved along. Today we're going to move into chapter 4, which is a little bit more abstract. It's the theory of individual behavior. It's what's called the rational consumer choice model. It's a model that allows us to analyze the decision to consume, given that consumers face prices and they are limited by the amount that they're able to spend by their income. So we have a very specific way of modeling that. It allows us to then derive a demand function from it. And what it also allows us to do is, if you go back to what we did last week, go from the sort of statistical analysis of a market, get to the demand of that market, the demand relationship that we estimate. And then from there, you can break that down into like the individual components of that demand via this model. You can look at when there are price changes, how much that is affecting people's willingness to substitute to another good versus overall feeling kind of poor because of the magnitude of what they were spending on relative to their overall income, making them feel poorer as their income increases. These are called the substitution and income effect. We'll talk about them on Thursday using this model to analyze that behavior. And then there's a couple of other applications we'll talk about at the end on Thursday as well. The point is to kind of build up the mechanics of the model and really understand the logic of it, and that's what today's going to be about. So basically, there's two main components to the model. There is the budget constraint that embodies the prices that a person faces, also the income that limits their ability to spend, and sort of what that means in terms of how much they could potentially consume ultimately in the simple world that we are examining in the model, which then extends to the more complicated, obviously, reality that we all exist in. And then the other part of the model is our own preferences for consuming. So if there's a couple of things that we can consume, then we have our own feelings about how much we value those things and how much we're willing to trade off one for another. So it's about interacting our own subjective trade-off between goods to that trade-off that the market expects us to make based on the prices of the goods relative to each other. So if you think about everything that we can buy in terms of just exchange value, not in monetary dollar terms, but in terms of like how much of other goods you can gain for them, then that is the market exchange rate, the exchange rate that is set for us, and that we face when we're trying to decide what we want to buy, consume, etc. So it's the interaction of both that market exchange rate and our own subjective exchange rate that gets us to our optimal choices of consumption, the things that we actually do wind up buying with our income. And so that's what the model is all about. It's all about trying to sort of reflect that behavior, and then there's a bunch of applications. You can do a bunch of things with it. It's a very powerful model. You see it in central bank models, components of it. You see it in all sorts of financial firms that do analysis on financial assets. Hedge funds, non-governmental agencies, government agencies. This model has all sorts of applications, but like anything else that is powerful in this world, it's going to have some complexity to it, and it's going to require you to kind of just like follow the logic of it. Don't get lost in it. Don't and if at any point you do miss something, then you have to just be conscious of the fact that you need to go back and kind of build up the knowledge again in order to kind of get the whole thing and how it works, and truly be able to understand it. In this class, I won't expect like very sophisticated applications of the model in terms of like the math and stuff. And I will highlight the things that I will expect you to know. But overall, it's about like kind of just having a general understanding of the model, having a general understanding of how the graphs work, and then like the important characteristics that I highlight throughout. And then of course there are practice exams online that you can check out, questions that sort of reflect how I expect you to understand this stuff. Ideally you've been working on that. Just kind of getting an idea of what's coming. Again, the exams I have online, questions from there are fair game for the exam. So are demonstration problems. So are homework problems. And then so if you haven't looked at the exams yet, they're structured as follows. There's 15 multiple choice, and then there's 4 open answer questions with multiple parts that could have some math. They could ask you to graph something, but likely no, or like get information from a graph that's presented to you. More computational stuff, definitely. Again, the questions can come from demonstration problems, can come from existing exams, and can also come from homework. And then the multiple choice is like kind of concept based, like terminology, principles, that kind of thing. So if you understand all that stuff, then overall you'll be good. Ideally, you've been making study guides for yourself, as I've suggested. As you finish each exam, you go through your notes once again, and then you kind of transcribe them into like a 1-page front and back study guide for a chapter with everything on there. And then you kind of just have that available to you right prior to an exam for all the chapters, and you can just start like kind of going through them, however many times you need to. Generally, it's going to be a lot of times to really get everything down. And then, of course, all the computations, you're practicing those homework problems, etc. So if you're taking that approach, you'll do fine. You still have a week to take that approach if you haven't taken any of that approach yet. There's still time. Make sure you make the best of this time. A week is a decent amount of time. I understand there's other things going on in your life, other classes, other life responsibilities, but this is what you do. This is your priority. It should be. Make this your priority and make the next week a success. I'd like to see that. As far as the exam goes, I need a green Scantron 8882-E form. I'll email today. Just throw it in there. Also, calculator. You can have one. It should be scientific. Phones are not allowed, and graphing calculators are not allowed either because they can save information. And that's just something to write with, because the open answer questions you'll answer on the form that I give you. Are there any questions about the exam, forthcoming exam, or anything else you want to ask about the class before I move on to the material? Yeah. Uh-huh. Right. So I talked about the mechanics of the market model when we covered it. So when you have a price below equilibrium, you're going to have an excess amount of demand and not enough supply, so there's going to be a shortage. So then you have all these people that are willing to buy things at higher prices that aren't able to. And so then they would start, if the price floor is not binding, meaning like it's not, the price just started below equilibrium, not it was set legally. If it was set legally, there's nothing that can be done. But if it wasn't set legally, then those people that are willing to pay more will start bidding up the price. And as they start bidding up the price, then other suppliers will come in who have higher marginal costs that weren't willing to supply at the lower price. And so they'll start supplying, and then eventually it'll get them up to the equilibrium. Yeah.
Yeah, I have one question about practice exam 1B. Says on number 2.
Wait, if there's a question about a specific question from a practice exam, put it on Moodle. I'll answer it there. I mean, on Piazza, I'll answer it there. Yeah. Any questions about logistics, how the class works, things that you are interested in me answering about, how you should be moving forward in the next week or whatever? All right. Yeah, homework and practice exam questions, ask them online on Piazza so everybody can see the answer, because not everybody's here and they might have the same questions. That's why it's a good place to ask those questions. And demonstration problems from the should be enough for the open answer parts. But as far as like the multiple choice, you need to understand all the concepts that I cover. Everything comes from the PowerPoints as far as like the material that I cover. So like the heart of the course is from the PowerPoints, and then any problems that you see that are not on the PowerPoints are extensions of problems that I have already done. So the logic of the problems are presented to you. But then I also have the homework videos to explain how to do the stuff that's on the homework. So there's a lot available to you. If you're truly dedicated to doing well, you can. There's no problem. I've had no problem in the past with people that are interested in doing well. They do well because they dedicate their time to using my materials properly. Other questions? All righty, let's move forward with this wonderful model on this wonderful Valentine's Day. Happy Valentine's Day, everybody. All right, so we'll establish the part of the model that that reflects our individual preferences. So it's a very subjective sort of formulation of this, because we are very subjective, right? Like we have different feelings about things on each individual person. So we have to be as general as possible. So the model, obviously, like any model, will make simplifications, and they won't apply to everything, but they generally apply. Like overall, they do a good job of like predicting behavior of consumers in general. So just always keep that in mind. Whenever you're covering anything in any class, like yes, you will always think, oh yeah, well there's this one thing that doesn't really apply to this, and it's true. There are always like what we call outliers, cases that don't necessarily fall within like the norm, the average. Yeah, always. There will always be exceptions, but in general, the things that are presented are things that there's a consensus about, that most people exhibit, or whatever system is being presented to you. At most, generally, you'll see those characteristics. So just just kind of go with it. So first we'll establish the consumer behavior side, then we'll establish the constraint side, which again embodies like that market restriction, like what the markets and prices and incomes sort of restrict us to be able to consume, because ultimately, realistically, we would want to consume as much as possible of everything anytime, right? So something needs to rein that in, and that is what prices do, and that is what our income does. So that's the other part of the model. And then we'll establish the consumer equilibrium, the interaction of the constraint with the preferences, sort of establishing, well, how does the model get us, and what does it look like within the model to be at that optimal point where a consumer is choosing the most preferred combination of goods that they can afford. And then we'll go beyond that on Thursday to finish off the chapter. So we're going to explain 4 basic properties of consumer preferences, just like some general properties that we inject into the model that capture most characteristics of people's preferences. And the preferences are set up as like a ranking system. So it's what we call the consumer's preference ordering. And then we'll talk about the ramifications for consumers, what are called indifference curves, which is what the preferences look like graphically. We'll illustrate how changes in prices and income impact an individual's opportunities. So once we have the model set up, we'll analyze how changes in prices and income sort of affect that optimal consumption bundle. Illustrate a consumer's equilibrium choice and how it changes in response to changes in prices and income. Separate the impact of a price change into substitution and income effects. Again, I mentioned that earlier, where you can use the model to kind of like deconstruct, like when people are changing their behavior because of a price change, like how much of that behavior is because of what they call the substitution effect, they're substituting between goods, and how much of that is because of an income effect where they overall feel poorer, which we'll talk about. Show how to derive an individual's demand from indifference curve analysis and market demand from a group of individual demands. So once we have it all down, we'll use the model to get to the demand curve that we've been working with. And apply the income leisure framework to illustrate the opportunities, incentives, and choices of workers and managers. And so that last part is just kind of like applications of the model, like kind of highlighting the versatility of its applicability. All right, let's start with consumer behavior. So we begin to develop a model to help us understand how consumers will respond to alternative choices that confront them. So of course, in general, a consumer is an individual who purchases goods and services from firms for the purpose of consumption. Everything has to be defined, but you guys know what a consumer is. In characterizing consumer behavior, there are two important but distinct factors to consider. There are the consumer opportunities, and then there are the consumer preferences. So the consumer opportunities represent the possible goods and services consumers can afford to consume. Again, reflecting that sort of market restriction that's set upon the preferences. And then, of course, there's consumer preferences, which determine which of these goods will be consumed. The distinction is important. Again, like there's certain things you want to consume, but there's only certain things you can afford to consume. So keeping the distinction in mind, let's begin by modeling consumer preferences with a brief review of the utility concept. So in your introductory micro course, you were introduced to this concept. It's how we in economics sort of measure satisfaction. We just call it utility. And ultimately, it's just a ranking system. So like something that has a utility of 10 is not preferred as much as something has a utility of 30. The fact that something has a utility of 30, which is 3 times the 10, doesn't mean anything. The only thing that matters is that 30 is greater than 10. So then the thing that has 30 utils is preferred to the thing that has 10 utils. So it's just a ranking system. The numbers themselves have no real value. They only have importance relative to each other. So the utility of a consumer is a measure of the satisfaction the consumer derives from the consumption of goods and services. An individual's utility function gives the total utility generated by her or his consumption bundle. The util is just an individual unit of utility. The marginal utility of a good or service is the change in total utility generated by consuming one additional unit of that good or service. So consuming one more unit gives you an extra unit of utility, which we call marginal utility. I'll show you how all this translates into the utility function in a second. Marginal utility is also the slope of the utility function. So anytime we say marginal anything, it's always going to be the slope of the function it's referring to. So marginal cost is the slope of the total cost curve. Marginal benefit is the slope of the total benefit curve, etc. So according to the principle of diminishing marginal utility, each successive unit of a good or service consumed adds less total utility than the prior unit consumed. So you've been waiting all week or all day, you're really hungry, you haven't been able to eat, you order a pizza, that first slice of pizza, delicious, amazing, gives you a huge amount of marginal utility, extra utility you gain from that one unit of pizza, as much as it possibly can be. Second slice of pizza, good, pretty much close to the first one, but not quite as good as the first one. So the marginal utility is positive, but it has diminished. It's not quite as much, doesn't give you quite as much satisfaction as that first slice. Eighth slice, definitely, your marginal utility has diminished quite a bit. Each additional unit gives you a positive amount of utility, gives you a positive amount of satisfaction from eating each additional unit of pizza, but not quite as much as the prior units. So we just assume this to be a characteristic of the relationship between a person's satisfaction and what they consume in general for most things. We assume that they have diminishing marginal utility. All right, so here's an example of a utility function. This is Casey. She likes clams. So here's her total utility on the y-axis, quantity of clams on the x-axis. So first clam, she's been waiting all week for that clam buffet. Gives her quite a bit of satisfaction utility. So her marginal utility, as we see on this table over here, so going from 0 clams to her first clam, her marginal utility is going to be 15 utils. So her total utility from eating 1 clam is 15 utils. And down here is the graph that's plotting the marginal utility. So we can get the slope of this point right here by getting the slope of the tangent line, which is what you do with calculus, which I'll introduce calculus in the second section of the course. So you weren't expected to do any calculus in this first part of the course. But anyway, you learned this concept at some point in your 103 class or in your business calculus course, wherever you took it. Anyway, so the slope of this line is being plotted here, and again, it represents the marginal utility. So the slope of this point here tells us that at that point, that additional unit gets the consumer, Casey, 15 additional units of utility, which is plotted here for the first unit. And it's plotted in between just to represent the fact that going from 0 to 1, you get the marginal utility of 15. Second clam makes her happy, but not quite as happy as the first. So her marginal utility is 13 from the second clam, getting her to a total utility from the 2 clams consumed to be 28. So that's this point here on her utility function. And here is the marginal utility plotted on the marginal utility curve. Again, reflecting the fact that marginal utility has diminished. And we can see that that trend continues as we go further. And how it looks as far as the utility function goes is that it is flattening out. That the fact that it is flattening out is telling us that there is diminishing marginal utility to the relationship between what she is consuming and how she feels about it. And of course, this downward sloping marginal utility curve also captures that characteristic. And then we also see it, of course, in the table here. We see the marginal utility is diminishing, going from 15, 13, 11, 9, 7, blah, blah, blah. All right, so having established some of the nuances of the utility concept, we can now continue with more characteristics of the consumer behavior model. So we're only going to assume that there's 2 goods in this economy just to simplify the world. Everything we talk about extends to the more complicated world, but it requires more sophisticated math that is beyond the scope of this course. So you don't have to worry about it. Just kind of understand the simple case, understand the logic of it. So the assumption, again, is made purely to simplify our analysis. All the conclusions that we draw from this 2-good setting remain valid when there are many goods. So we'll let X represent the quantity of one good and Y represent the quantity of the other good. So every choice of these 2 goods can be called a consumption bundle, is called a consumption bundle. So it's a combination of goods and services that a person consumes. So we all have consumption bundles. You can think about it as maybe everything we buy in 1 month. So everything you buy in 1 month with your income that month is your consumption bundle. It's made up of everything you bought. And if you were to like write it down, it would be like the quantities of each. And that would all make up your consumption bundle. In a 2-good world, a consumption bundle is only made up of some of good X and some of good Y. Assume a consumer is able to order his or her preferences for alternative bundles or combinations of goods from best to worst, depending on the level of utility gain. So they can always rank consumption bundles, right? You can have a consumption bundle with just X and no Y. You can have a consumption bundle of just Y and no X. Or you can have consumption bundles that vary how much X and Y they include. And then you can rank all of those. We assume that you are able to rank them in order of preference. And again, that ranking system is just basically utils. So we'll let this symbol here, this greater than kind of curvy symbol, denote the ordering. And write A is preferred to B whenever the consumer prefers bundle A to bundle B. If the consumer views the 2 bundles as equally satisfying, which is possible, we'll say that he or she is indifferent between A and B, and use the tilde to denote that as a shorthand notation, just like the squiggly line. And the preference ordering is assumed to satisfy 4 basic properties. I'll go through them in turn. I'll just list them right now. The first one is completeness. The second one is more is better. The third one is diminishing marginal rate of substitution. And the fourth one is transitivity. All right, so let's go through the first property, completeness. So here, basically, we assume that a consumer is able to rank all bundles that they have as options for them. So for any 2 bundles, A and B, either A is preferred to B, either B is preferred to A, or the consumer is going to be indifferent between A and B, meaning that they are equally preferred by the consumer. So those are the 3 possible options for ranking, and therefore we assume that all bundles will be ranked in this way. So there is completeness with respect to how a consumer views all the bundles. By assuming the preferences are complete, we assume the consumer is capable of expressing a preference for or an indifference among all bundles. If the consumer cannot express his or her own preference for or an indifference among goods, the manager can hardly predict that individual consumption patterns with reasonable accuracy. So this assumption is very important for the applicability of the model. All right, second property, more is better. So it's always assumed that consumers want more, and more is better than less. Obviously, that's not always the case, and people are sometimes willing to just accept less, and that they're fine with that. But just in the model, we assume that more is better, and you do see it in reality. I mean, we see the distribution of income in our world. It's very polarized. You see that at least 50% of the world's income belongs to, like the top 1% of the world population. So, I mean, more is better ultimately in the economy. You see it. Like, as much as people can take, they will take. So if bundle A has at least as much of every good as bundle B, and more of some good, let's say, so you have 2 bundles, and A has at least as much as B, but more of some goods, then A will be preferred to B because more is better. So if more is better, the consumer views the products under consideration as goods instead of bads. So whenever we're talking about goods, this is what we're actually talking about. Basically, the fact that people prefer more rather than less. And if there is a situation where they prefer less rather than more, we call them bads. So graphically, this implies that as we move in the northeast direction, we move to bundles that the consumer views as being better than the bundles to the southwest. And essentially, like, these properties are embodied in what's called an indifference curve. An indifference curve is the geometric representation of this principle in which along the curve, every consumption bundle yields the same total utility. So ultimately, what we're looking at here when we're talking about a 2-good world is a relationship between those 2 goods and the utility they gain from the consumption bundles of those 2 goods. So what we saw for Casey, we saw her utility as a function of just 1 good. So her consumption bundle is made up of just 1 good. And so we just plotted it on the XY axis. It was a flat curve, whatever. But when you throw in another good in there and you have utility as a function of 2 goods, that becomes a 3-dimensional relationship, and you cannot represent that 2-dimensionally in a flat plane. So this represents a quarter of what the shape of the utility function actually winds up being. You don't need to know this. This is just to give you intuition about what we're dealing with down here, which you'll find out about in a second. So the relationship between these 3 variables winds up looking like a bowl. It's like a bowl-shaped relationship. Like, whenever you get a 3-dimensional relationship, it's going to make some kind of like geometric shape that is like 3-dimensional. So kind of like the hat, if you imagine it kind of being like kind of with a rounded edge, all sides kind of leading to a point. And where like the height of the hat is the utility, and then the amount of X is the amount of good X, and that could be like on the X-axis, or it would be down here on the X-axis, and the amount of Y would be on the Y-axis, and that's sort of like on the flat plane. And then as you go higher, the consumption bundles of X and Y yield higher levels of utility at each level of this like rounded shape. So this thing here is like a quarter of this rounded shape. So utility is on what's called the Z-axis, which is the one that comes out from the flat plane. The flat plane. I know. It's like I don't know what happened. Yeah. The flat plane. Anyway, so here's X and Y, the flat plane, and here's our utility function. So if you go, and remember, it's got a rounded edge. So if you want to just examine consumption bundles that all yield the same level of utility, what you do is you slice that three-dimensional bowl shape at some height that corresponds to a level of utility, and then you flatten it down. So like, let's say you slice this utility function at this level, representing a level of 30 utils for all consumption bundles along it. Well, if you flatten that down, you get this curve right here, which we call an indifference curve. So if you plot good y on the y-axis and good x on the x-axis, all the consumption bundles, all the combinations of x and y that are embodied in that curve yield the same level of satisfaction, utility. So a consumer is indifferent between those two bundles or all those bundles along in a given indifference curve. Let's say you slice the utility function at the next, at a lower level, let's say at a level corresponding to 20 utils. Slice that, you get that rounded edge there. Again, if you flatten that down, you get this indifference curve. Corresponding to a level of 20 utils, and all consumption bundles, so this consumption bundle here that has a lot of x and a little bit of y, and then this consumption bundle here that has a lot of y and a little bit of x, yield the same level of utility satisfaction to the consumer, and therefore the consumer is indifferent between all consumption bundles along that indifference curve and every indifference curve. So there's like a bunch of indifference curves. We could slice this at any level and flatten them down. You don't see them all the time, but they're always there. So graphically, again, this implies that as we move to the northeast direction, we move to bundles that the consumer views as being better than bundles to the southwest. So as you move from the origin here, from the 0, 0 point, and you move northeast this way, you're going to get consumption bundles that the consumer prefers more to those that are down here that are consumption bundles that have less of both goods. So again, an indifference curve, again, these curves is a geometric representation of this principle in which along the curve, every consumption bundle yields the same total utility. Again, the consumer is indifferent between any consumption bundle along an indifference curve. Slicing this however many times, only twice or maybe 30, however many at different levels of utility, flattening them down to get this sort of flat graph with the rounded edges is what's called an indifference map. It represents the entire utility function of an individual as a collection of indifference curves in which each curve corresponds to a different total utility. The shape of the indifference curve depends on the consumer's preferences. So not all indifference curves are going to look exactly the same. You can represent a consumer's preferences differently depending on whether you draw them kind of flat or kind of steep. And again, it represents like their subjective trade-off that they're willing to make of one good to another, depending on how much they like the goods relative to each other. So one important way to summarize information about a consumer's preferences is in terms of what's called the marginal rate of substitution, which is the slope of the indifference curve, the rate at which one consumer is willing to exchange one good for another in order to remain as well off as before. So the marginal rate of substitution is the rate at which a consumer is willing to substitute one good for another good and still maintain the same level of utility. The slope of the indifference curve is the marginal rate of substitution. Let's focus on what happens when we move a short distance down the indifference curve, trading off a small increase in good X in place of a small decrease in good Y. In general, the change in total utility caused by a small change in consumption of a good is equal to the change in consumption multiplied by the marginal utility of that good. So we'll let the marginal utility of good X equal MUX. So the extra utility this consumer gets from consuming an additional unit of X is their marginal utility of good X. We represent it as MUX. We'll let the marginal utility of good Y equal MUY. So a change in the consumption of good X. So let's say the consumer is consuming this consumption bundle here with a relatively high amount of Y and a little amount of X. The consumer wants to switch their consumption bundle, consume more of X, consume less of Y, so they're going to move down along their indifference curve because they want to maintain the same level of satisfaction utility. And the only way you can do that is to consume consumption bundles on the same indifference curve. So a change in the consumption of good X from here to here, in which X is being increased, will be represented as, again, change, triangle, change of QX. That will carry a change in total utility equal to the change in QX times the marginal utility of X. So going from here to here, we're going to increase the amount of X, and that's going to carry some additional utility with it. But also, as we're moving from that consumption bundle to this one, we are decreasing the amount of Y that is being consumed by the consumer. And so that's going to carry a loss in utility, right? A loss in marginal utility of Y. So you're going to have a change in the quantity of Y, which is a decrease from this point to this point of how much Y is being consumed. And that will carry a change in total utility equal to the marginal utility of Y times that amount that's being changed in consumption, in this case, a decrease in Y. So along the indifference curve, as you're moving from one consumption bundle to another, the change in total utility has to be equivalent in terms of how much utility you're getting from one consumption bundle to another, in order to maintain the fact that the consumption bundles, the consumer views them as being, of equal utility value. So the consumer has to be indifferent between the two along an indifference curve, and therefore this relationship has to hold. Remember, these are numbers here, so these can be manipulated algebraically like you would any numbers in an equation. Yes?
So that means if the change in quantity of Y is negative number, that whole number would become a positive number.
So you're lowering, this is negative here, and then this has to be positive here. Because there's a trade-off being made, like the number will wind up being negative. So we're looking at this. I'm deriving the slope of it, and the slope is going to be negative because it's the slope embodies a trade-off, a subjective trade-off, but a trade-off nonetheless.
And if you're going the opposite way, it's still going to be a negative.
Yeah, because in order to go the opposite way, you still have to decrease amount of X, right, in order to get more Y. All right, so you can manipulate this in order to derive just your general expression for a slope, right? In this case, we have good Y and then good X, so it'll be the change in Y over the change in X. So to figure out how this translates into the slope of the indifference curve, we're going to rearrange this. So I'm going to divide both sides here by the marginal utility of Y to get that on the right. And now I'm left with the negative QY on the left equals this expression here. And now I'm going to divide both sides by the change in the quantity of X to get that to the left-hand side. So that cancels out there. And so therefore, we see that the slope of our indifference curve, the change in the quantity of Y with respect to the change in the quantity of X, is going to be equivalent to this expression here. The ratio of the marginal utility of good X to the marginal utility of good Y. So within the logic of the model, the slope of our indifference curve has an equal expression, which is this one here, the ratio of the marginal utility of X to the marginal utility of Y. Sometimes people get this mixed up because they always think, oh, well, a slope has the change in Y, so the Y variable change in the numerator and the X variable change in the denominator. But we saw here that to derive this expression, that we wound up getting the marginal utility of the good on the X-axis on the numerator and the marginal utility of the good on the Y-axis on the denominator. So you just kind of have to keep that organized in your head, because this is going to wind up playing an important role in getting us to equilibrium and what the equilibrium means. So just keep that in mind. Yeah. Yeah, it will always be negative. Yeah. Why would you ask otherwise? Why would you consider otherwise, though? Like what? Was there an opposite case that you were thinking? Right. It will always. Yeah. But okay, so when you're presenting information, you have to just point everything out. So of course I'm going to point that out. But yeah, of course, logically, it will always be negative. And so I won't always have the negative there. Just always know that it's there, because we're always talking about a trade-off. But what's important here is this. So what the again, you just have to remember what the slope of the indifference curve represents, what's called the marginal rate of substitution. It's the rate at which a consumer is willing to trade off one good for another in order to maintain their overall level of satisfaction. And it can be expressed as the ratio of the marginal utility on the x-axis to the marginal utility of the good on the y-axis. All right, so again, the left-hand side is an approximation to the slope of the indifference curve. It's the rate at which the consumer is willing to trade x in place of y. The right-hand side is the ratio of the marginal utility of good x to the marginal utility of good y, and they are equivalent. So the marginal rate of substitution associated with moving from, let's say, point A to point B differs from the rate at which the consumer is willing to substitute between B and C. So we have what's called diminishing marginal utility. Diminishing marginal rate of substitution, which is due to diminishing marginal utility. That characteristic that I talked about earlier when I was talking about an individual's relationship to their utility of anything they consume. The fact that as we consume more of things, it gives us pleasure, but like not as much pleasure as the prior thing. So we have diminishing marginal utility. Because of that, the marginal rate of substitution along an indifference curve tends to diminish as well. So if we're moving from B to C, the consumer here is going to consume one more unit of X, and they're willing to consume one more unit of X by giving up 1 unit of Y in order to maintain their level of satisfaction. And that's different than going from A to B. Going from A to B, in order to increase the amount that they're going to consume of X by 1 unit, they're willing to give up 2 units of Y for it, which means that they value that extra unit that going from 1 to 2 more than they value that extra unit going from 2 to 3. So the reason is that this indifference curve satisfies the property of diminishing marginal rate of substitution. As the consumer consumes more of good X, the amount of good Y he or she is willing to give up to obtain another unit of good X decreases. So this feature arises from diminishing marginal utility, right? So if you just think about the relationship between the consumer and good X, good 1 is going to be worth a lot more to the consumer in terms of utility than good 2, than the second unit of X. And then the third unit is going to be worth less in utility than the second one, and so on and so forth, right? So therefore, if you're talking about exchanging one good for another and sort of valuing that exchange in terms of utility, then we see that the exchange rate between X and Y going from that first to second is going to be higher than the exchange rate going from 2 to 3 because, again, like there's diminishing marginal utility with respect to consuming more of X. So you need less of Y to substitute for it in order to maintain your overall level of satisfaction along an indifference curve so that you can be indifferent between the consumption bundles. So again, recall that when a consumer has diminishing marginal utility, consumption of another good generates a smaller increase in total utility than the previous unit consumed. This assumption implies that indifference curves are convex from the origin. So this characteristic that I just described is reflected geometrically, graphically, as a curve that's kind of curved out from the origin. It's bowed out from the origin, as we say, or also mathematically we say it's just convex, or from calculus, convex up. Concave up. Yeah. D represents a consumption bundle that is less preferred to any of these because it has less of both. So the more is better assumption tells us that it's preferred to less than any along this indifference curve. And it also reflects the fact that there is an indifference curve that is below this indifference curve that represents consumption bundles that are all preferred less than A, B, or C. Of course, yeah, combinations of X and Y. Yeah. So this D represents 1 unit of Y and 1 unit of X. All right, and the final property is transitivity for any 3 bundles, A, B, and C. If A is preferred to B, and let's say B is preferred to C, then A will be preferred to C. Similarly, if one is indifferent between A and B, and one is also indifferent between B and C, then By transitivity, one will also be indifferent between A and C. So the implication of these four properties, completeness, more is better, diminishing marginal rate of substitution, and transitivity are conveniently summarized in the figure which depicts the three indifference curves. So our indifference map embodies these four properties. Every bundle on indifference curve 3 is preferred to those on indifference curve 2, and every bundle on indifference curve 2 is preferred to those on indifference curve 1. We know that as we move further out from the origin, that the indifference curves represent higher levels of utility along the indifference curve. So therefore, all indifference curves further away from the origin will contain consumption bundles that are going to be more preferred to consumption bundles on indifference curves closer to the origin. The three indifference curves are convex and do not cross. So they exhibit diminishing marginal rate of substitution, and they do not cross. If they did cross, then that would violate some of our properties, because you would wind up with consumption bundles that are equally preferred to others that are also on the same indifference curves as those that are not equally preferred to each other, which doesn't make any sense logically as far as what we've established the properties to be that embody the preferences of a consumer, which we demonstrate graphically here, and is embodied in the mathematical relationship between utility and the consumption bundles. So curves farther away from the origin imply higher levels of satisfaction than curves closer to the origin, as I mentioned. All right, so that is the preferences side. Let's talk about the market side of things, the interaction of our preferences with the market. The market in the model has to be represented in a way that logically makes sense. All right, so in making decisions, individuals face constraints, right? We have preferences over things, but again, if we're left to our own devices, our preferences would just run wild, and we would just like consume as much as we prefer to consume. But we live in a scarce world. Economics is all about sort of allocating scarce resources to their most efficient use in our economy, and so something has to rein in our preferences, because there isn't enough to go around. And what reins us in are prices. So there are legal constraints, time constraints, physical constraints, and of course, most important here, budget constraints. We'll examine the role prices and income play in constraining consumer behavior via the budget constraint. So simply stated, the budget constraint restricts consumer behavior by forcing the consumer to select a bundle of goods that is affordable. So if we let M represent the consumer's income, we've been using M to represent income thus far, and that will be the case throughout the course. And it can be any amount of income. And we let P subscript X and P subscript Y represent the prices of goods X and Y respectively. Again, we let X and Y represent the quantities of good X and Y respectively. All right, so given this notation, the opportunity set, also known as the budget set, may be expressed mathematically as the total value of good X that is consumed, so the amount of X times its price, P of X, plus the total value of all Y that is consumed, the amount of Y consumed, times its price, PY, and that's going to be less than or equal to income, right? A person is going to either spend all of her income in this very simple world in which only X and Y exist, and the amount that she can buy has to be equal or less than the income that she earns. And this, again, this relationship is a mathematical formulation of what's called the budget set, and it represents the consumption bundles of goods that a consumer can afford. The consumer's expenditures on good X plus her expenditures on good Y do not exceed the consumer's income, is essentially what that is telling us. If the consumer spends his or her entire income on the two goods, the equation holds with equality. So that's what we're going to assume. We're going to assume that the consumer is exhausting all of her income in what we're going to consider in this course. A more realistic case would be that that's not the case, and there are savings, and there's way to account for that in the model, but we're not going to go into that case here. But you can. Like, the model can deal with more sort of realistic circumstances, And if you were to go further in economics, you would see the more intricate applications and dynamics of the model. All right, so graphically, this can be represented as a budget line. And again, it's the bundles of goods that exhaust a consumer's income. So along the line will be all the consumption bundles that the consumer can afford and costs all of her income. So it's useful to manipulate the equation for the budget line to obtain an alternate expression for the budget constraint in your standard slope-intercept form of a line. The slope-intercept form of an equation of the line with slope little m and y-intercept b is equal to y equals mx plus b. So just keep in mind that I'm using another m here, but it's lowercase. So when you're using upper and lower cases in any kind of class that's using notation, it usually corresponds to two different variables. So this is not a variable. Obviously, it's a parameter. It's a slope. But I wanted to use the normal specification that you learn in your math classes. Yes?
In the definition of budget line, what do you mean by exhaust?
Exhaust, so using all of. Yeah, so
And the formula for that is the one above, right?
it's this one here, yeah. But we're gonna turn it into the equation of a line right now. All right, so you've got, again, this relationship here that tells us that the consumer is using all of her income M to buy some of Y and some of X, and again, we're valuing those in terms of their prices. So this is our starting point, and we want to get here. So you just want to solve for Y in terms of X. So we're going to subtract this term from both sides, Px x, and get that on the right, and then divide both sides by the price of Y. And so then that gets us to the slope-intercept form for our budget line, which I'll talk more about right now when I will graph it. But I don't expect you to know how to derive this. I need you to understand what all of this means, and then kind of just understand what this equation means. But I would never ask you to like go from this equation to this equation. But I always like to show as much as possible. All right. So this tells us that Y is a linear function of X. And it has a vertical intercept, which is income divided by the price of Y. So income divided by the price of Y tells us how much of Y the consumer would purchase if she only bought Y, right? And then it also tells us the slope of our budget line, which is the negative ratio of the price of X to the price of Y. So again, you can go from this expression to the slope-intercept form, which has more information in it. All right, so this is the plotted line. Again, we have good Y on the Y-axis, good X on the X-axis, and this is our budget line. It represents a budget constraint. So the budget set is not just the line, but everything within the line as well. The shaded area represents the consumer's budget set or their opportunity set. If you remember your introductory micro and macro courses, you covered the production possibility frontier, which is essentially the same model, but from the production side, representing the various combinations of things that can be produced in a world where only two things can be produced. And there was a trade-off embodied along the line. If you were within the line, you were not using all your productive resources to produce. And when you were producing along the line, you were producing as much as you could given your productive resources. So this is basically, it works exactly the same, but it's from the consumption side. So you can think of it as a consumption possibilities frontier. If you remember the mechanics of the production possibility frontier, it's the same, and you can kind of bring that in if you want to your understanding of this, but it's not difficult to understand. So again, the budget set represents all the combinations of goods and services a consumer can consume. But the budget line represents those combinations of the goods that will exhaust, completely use up a person's income. So again, if you have some consumption bundle, let's say G, that has some X and Y in it, and it represents an affordable combination of X and Y, the consumer can afford that consumption bundle. Again, any point above the shaded area, such as H, that goes beyond our budget set, our budget set embodying this budget triangle, represents combinations of goods that are not affordable, right? The consumer cannot afford this much Y and this much X. So the upper boundary of the budget set is the budget line, as I already stated. Again, it has that equation we just derived. So if a consumer spends all of her or his entire income on good X, the expenditure on good X would exactly equal the consumer's income. So if you divide the income by the price of X, that'll give you the most a consumer can consume of good X. Where would that land on this graph? X-intercept, right? Exactly, down here. So again, it would be our relationship that we established earlier between everything that can be bought and income, but you just put Y equal to 0, so then you're just left with this relationship, and you divide both sides by the price of X. Then you get the most that the consumer can buy of X. So that's that amount, which is, of course, the X-intercept here. Again, that is a combination of goods where 0 Y is being purchased and as much of X is being purchased as can be afforded. Horizontal intercept of the budget line. Similarly, if the consumer spent her entire income on Y, expenditures on Y would exactly equal income. So then we've got, X equals 0. So then we're just left with this in our equivalent expression for our budget set. Consequently, the maximum quantity of good Y that is affordable is going to then equal, if you divide this by both sides, again, it's going to equal our income divided by the price of Y, which is going to be the Y-intercept, which of course is the Y-intercept from the line equation that we derived earlier. The slope of the budget line, negative PX over PY, represents that market rate of substitution I talked about in the introduction, where because things have prices, there's a rate at which you can exchange one good for another. And if you think of it in real terms, not in terms of like monetary dollar values, but you think of it like in terms of like how much you can exchange one thing for another, that is the market rate of substitution. So it's the rate at which one good can be traded for another in the market. And it winds up being the slope of our budget line. Another way to understand this is to consider the opportunity cost of consuming only good X. So let's say you only consumed good X. In order to only consume good X, you're giving something up, right? Opportunity cost is the value of everything that must be given up in order to do something. And so in order to consume all of good X, you're giving up all of Y, right? That can be consumed with your income, right? So the opportunity cost is not to consume only good Y with one's income M, which is what I just said. I said it clearer than I stated there. Sorry about that. Anyway, so the opportunity cost of only consuming good X is going to be in terms of Y. So it's the total value of Y consumed is going to be the opportunity cost of consuming the total possible of X consumed. So if we put our total amount of Y that can be consumed in the numerator, which we know is income divided by the price of Y, over the total amount of X that can be consumed, which is income divided by the price of X, then we get this expression here, which is a ratio divided by a ratio. A ratio divided by a ratio is equivalent to a ratio times the reciprocal of the ratio on the denominator, right? So we have M over PY. And the negative there, again, is just to represent that there's a trade-off. As you're buying more of one thing, you have to give up some of the other thing. So M over PY times PX over M, right? The reciprocal of it's just properties of ratios. M's cancel out, and thus you're left with our expression for the slope of the budget line, which also tells us the opportunity cost of consuming X in terms of Y. So the market rate of substitution tells us how much of Y we are giving up as we are consuming one additional unit of good X. It's also known as the relative price of good X to good Y.
You're saying the slope of the budget line, so even if it's vice versa, it's still going to be PX.
No, you would take the reciprocal, right?
You're going the other way.
Yeah, if you're going the other way, then the opportunity cost is going to be in terms of the other goods. So you have to just flip the slope. Yeah. All right, so to gain more insight into this concept, consider the figure which represents a budget line for a consumer who has $10 in income and faces a price of $1 for good X and a price of $2 for good Y. If we substitute these values of PX, PY, and M into the formula for the budget line, so here's our general specification of the formula for the budget line. We're going to throw in a price of X to be $1, price of Y to be $2. So remember, much like our marginal rate of substitution that had the marginal utility of good X over the marginal utility of good Y, the slope of the budget line, because of the way we derive it, you wind up with the price of X over the price of Y here. So just remember that as well, or else you're going to get mixed up. Like, it's important to realize that that's an equivalent way of expressing the slope, and it's reflective of the characteristics of the model. All right, so if we plug our stuff in, the most that can be bought of good Y is going to be equal to income, which is $10, divided by the price of Y, which is 2. So that's going to be 5. So that'll be our Y-intercept there. And then the negative ratio of the price of X to the price of Y is equal to negative 1/2. And what that basically tells us is that in this world, given the prices this consumer faces, in order to consume an additional unit of good X, they must give up half a unit of Y. And if you take the reciprocal of that, it'll tell you the opportunity cost of Y in terms of X. So in order to gain an additional unit of Y, the consumer has to give up 2 units of X. All right, so you have 5 equal to, Y equals 5 minus 1/2 X. That's our equation for our budget line. We observe that the vertical intercept of the budget line is 5, as I mentioned. The reason the slope of the budget line represents the market rate of substitution between the two goods is as follows. So suppose the consumer purchased bundle A, let's say, which has 3 units of good Y and 4 units of good X. If the consumer purchased bundle B instead, so if the consumer decided to go from that bundle to this bundle that has 2 units of X and 4 units of Y, then she would gain an additional unit of Y. But to afford this, she has to give up, obviously, 2 units of X. So for every unit of good Y the consumer purchases, she must give up 2 units of good X in order to be able to afford the additional unit of good Y. So that's the rate of substitution that the market forces on the consumer, right? Just based on the fact that there's prices in the world. Thus, the market rate of substitution is going to equal the change in Y over the change in X, which is equal 1/2, which is the slope of our budget line. In terms of the relative price perspective, X is worth 1/2 a unit of Y, and Y is worth 2 units of X. So there's different ways to look at the meaning of the model, to characterize it. It has a lot of information. It's not just a line, right? You saw basic equations for lines in your algebra courses, whatever. You thought, okay, it's some simple whatever relation between two variables. When you throw it into a model, it winds up having a lot of meaning, and you can extract a lot from it. So in the two good case, the relative prices are reciprocals, as I mentioned. Now let's look at what happens when there's a change in income. So let's say you're in some normal world like this, but all of a sudden income has changed. Either it's increased or decreased for the consumer. So the opportunity set of the consumer depends on market prices and the consumer's income. As these parameters change, so will the consumer's opportunities. We'll now examine the effects on the opportunity set of changes in income by assuming that prices remain constant. My mom sent me a happy Valentine's Day text message. Anyway, all right. Suppose the consumer's initial income is M naught, whatever. Some amount of income. It could be the $10 we were talking about, whatever. It's a container, it's general. What happens if that amount increases, let's say, to M1? So let's say the minimum wage of the consumer goes up, or like they get a raise at their job, something. So recall that the slope of the budget line is given by the negative ratio of the price of X to the price of Y. Again, reflecting the market rate of substitution. So under the assumption that prices remain unchanged because just income is changing, the increase in income will not affect the slope of the budget line, right? So therefore, what is that going to look like graphically when an income changes as far as this line goes? It's just going to shift, right? There's going to be a parallel shift. The slope won't be affected because prices aren't changing. and the slope represents the market rate of substitution between the goods. But we do know that the vertical and horizontal intercepts of the line both increase as the consumer's income increases because more of each good can be purchased at the higher income. So when income increases from that amount M0 to M1, the budget line again has a parallel shift to the right when income goes up. This reflects an increase in the consumer's opportunity set because more goods are affordable after the increase in income than before. Similarly, if incomes decrease, so if we were to start again at that point where income is equal to M0, and let's say incomes were going to be cut, maybe the person's laid off, maybe they got a salary cut, whatever, then we know that the total amount of each good that the consumer can buy will go down, and the consumer's overall opportunity set, consumption set, is going to go down. So that's what happens when there's a change in income. Now let's look at what happens when there's a change in prices. So we know that, again, the slope of the budget line represents the rate at which you can trade off one good for another in the market. It's the market rate of substitution, it's the relative price, it's the opportunity cost of one good in terms of another, different ways of looking at the same thing. If a price of one good changes, then that's going to affect that market rate of substitution, right? So it's going to affect the slope of the line. It's also going to affect the intercept of the good that is having its price changed. So suppose the consumer's income remains fixed at some level M, but the price of good decreases, in this case from some initial price P0x to some lower price P1x. So the price of something goes down, that means you can buy more of it, right? Also suppose the price of good Y remains unchanged. So the reduction in the price of X changes the slope. So you're going to have a smaller number up here, making it flatter than before. So the slope is going to get flatter. So you're going to get, this is our initial budget line here with the initial prices of PX not there. Since the maximum amount of good Y that can be purchased, again, is equal to the income divided by the price of Y, a reduction in the price of good X does not change the Y-intercept of the budget line. But the maximum amount of good X that can be purchased at the lower price is now greater. So therefore, we will have a new intercept for the X axis, which represents a greater amount of good X that can now be bought at the lower price. So the ultimate effect of a reduction in the price of good X is to rotate the budget line counterclockwise or outward, right? Expanding the consumption opportunity set, also changing the market rate of substitution, right? So now the market rate of substitution is smaller. Why? Because good X costs less. So therefore, the trade-off between X and Y will also decrease. So that means that you don't need as much X you don't need to give up as much Y to get X now, because that market rate of substitution has gone down because X's price has gone down. And how do prices go down? Well, there's a supply curve, there's a demand curve. Something happened. It brought the equilibrium price of that good down. So remember, there's other stuff happening in this world. Similarly, an increase in the price of good X leads to a clockwise rotation of the budget line. So if this price were to go up, then you have your income divided by a higher price, a bigger number, which means that our intercept would go down, representing the fact that you can buy less of the good now if you spent all your money on it. And that would bring the budget line in. All right, why don't we just cut it off there? I don't want to go into the equilibrium because that's a whole other thing. So you've got the two components. Make sure you understand them, how they work. I suggest getting ahead, kind of figuring this out on your own. Also, there are lectures from last semester on my YouTube channel if you want to get ahead in the lecture. Just kind of getting this down now so you can start preparing for the exam. Yeah. No, we have a class on Thursday. The exam is a week from today.
Yeah.
All right. The exam is a week from today, but I wanted to let you know about it today in case I don't see you on Thursday. Anyway, have a good couple of days. I'll see you on Thursday.